Good morning. Today's session involves problems in second order reactions, problems in third order reactions, then various techniques adopted to follow the kinetics, and problems in various techniques. And if time permits, you will see that the effect of temperature on the rate and K and the Arrhenius equation. We will see one by one, and today's models we expect to finish within this one. If time permits, we will know this second order kinetics. What are the equations to be used in the second order kinetics? The general equation, from the general equation, you can see that K2 into T is equal to 1 by AT power 1 by AT minus 1 by A naught. This is the general kinetic equation for a general. Here only one concentration term is involved. Here this is derived based upon the assumption A giving the product. Only one reactant is present and it is undergoing second order kinetic. Therefore, the concentration of A initially is A naught, and the concentration of various time is given by AT, and this is the simplest equation. Suppose anybody gives the 2A giving the product. It is following the second order kinetic. Only for 1 mole of A, this is the equation. If 2A is present, just to multiply it by 2 is equal to something. If 3 by 2 A gives a product, just to multiply it by 3 by 2 and so on. We will first see this simple order equation, then we will go for the difficulty level. And you can make use of this equation. What are the problems that can be asked? What are the variables? The time is variable and the amount left after the time is variable. The initial concentration is a constant and A2 is a constant. Therefore, how many kinds of problems can be given in this? Only 2 kinds of problems. At the time t, say 3 minutes or 5 minutes after this, what would be the amount left? AT can be calculated. Once amount left is calculated, you can calculate what is the amount reacted. The AT is nothing but amount left is nothing but initial concentration minus the amount reacted equal to AT. Therefore, if you calculate here the AT, you can calculate the X, the amount that is consumed. Therefore, this is the first equation. And this equation can be adapted. What is the relationship between the time for the completion of this one and the time for the completion of 3/4 or T7 by 8 time relationship between T half? That can be done using this formula. However, if time taken for 20% completion is given, time taken for 20% completion is given, what is the time taken for 80% completion, or 10% is given, what is the time taken for 55% completion? For this equation can be simplified. It should be made shortcut. And you can make use of that formula for calculating this type of equation. What is the equation we have derived for the zero order reaction? X1 by T1 is equal to X2 by T2. This is for zero order reaction. In the second order reaction, the shortcut is nothing but A minus X1. You should add this one, A minus X2. You can make use of this equation to calculate what is the relationship between the time for the completion of one concentration to the time for the completion of another concentration. Or otherwise give the relationship between 7 by 8 completion to 50% completion. You can go for using that equation. Therefore, you should make use of either of these equations for doing problems in this one. And the graphical representation, sometimes the problems may be asked in the graphical representation of this one. In the how to convert this equation into graphical representation. And here we have seen two variables are there. One is the temperature variable and another is the AT, the amount reacted. The two variable, one is taken in the y-axis and another is taken in the x-axis. Which is taken in the y-axis, which is taken in the x-axis. Depending upon that, your graph will be slightly changed. Now, we will put this t as a variable, we will plot in the y-axis and now bring this k2 in the other side. K2 into a minus x minus 1 by k2 into a naught. This is for a one variable. Or you can put the a minus x variable in the y-axis and t in the x-axis. Accordingly, you can rewrite like this. 1 by a minus x is equal to, bring this here, k2 into t plus 1 by a naught. Only two way you can represent the graphical representation for the second order. And here, if you plot the the time versus variable 1 by a minus x. Here you will get a straight line y, this is x, and this is constant mx minus constant and a naught constant minus c. Therefore, you will get a positive slope, but that line will not pass through the origin, but it will catch the y-intercept in the negative direction. This is a y-intercept, this is a positive, 0 and minus. Therefore, your equation with straight line would be like this. And the slope is equal to 1 by k2. The slope is equal to 1 by k2. Now we have plotted this one. And the equation is like this. A negative intercept and a positive slope. And the slope is equal to 1 by k2. Now we are going to plot this one. The plot is how this one here. In the y-axis, we have taken 1 minus x. And the x-axis, you will get the t. And you once again, this is a y, this is a m, this is x, this is c. Now you get the same straight line with the positive slope, but that straight line will cut the y-intercept in the plus quadrant, not the minus quadrant as in the earlier. Therefore, now you will get this type of equation. This is 1 by a naught. And here this value is minus 1 by k2 a naught. This is the difference between these two ones. And here the slope is equal to k2. Therefore, either this one and that one, using this one, you can answer this problem. The initial concentration of each reactant is C. In the second order reaction, X mole of each reactant is consumed in time t. The graph of 1 by C minus X versus T gives a straight line, with option A, slope is equal to 1 by K2C, and the intercept is equal to rate constant. Option B, slope is equal to rate constant and the intercept is equal to 1 by C. Option C, slope is equal to 1 by rate constant and the intercept is equal to minus 1 by K2C. Option D, slope is equal to rate constant and the intercept is equal to 0. If a plot பண்ணியாச்சு, what is the correct answer? Tell me the answer. Tell me the answer. Anybody?
Option B, sir.
Option B. Another is given. The option C is applicable only when for which type of graphical representation. This representation, that would be the 1 by plotting t versus 1 by x. அப்படின்னு ஒரு இது கொடுத்தாங்கன்னா you will get the like this. Therefore, by rearranging the equation, you can plot in two ways from which you can give the values or some equations or some parameters are given. You can also make use of this representation and find out whether we have to use slope is equal to 1 by K2 or slope is equal to K2 or minus K2 or anything is present along with it. This is the way you can apply the equation for any order of the reaction. Okay, this is the graphical representation. Then the second, this is the first equation. From the first equation, we have given the shortcut to calculate the time taken for the completion in various percentages given. You can make use of this. And then another kind of this, we are going to use the T half of the second order reaction. The T half of the second order reaction, it can be derived from the general equation, and the T half for the general equation is given by 1 by K2 into A naught. It is the T half, is not. Have you derived this as 1 by K2 into A naught, initial concentration. We have derived one thing, the T half of any half-life period is, depending upon the initial concentration, inversely proportional. The concentration increases 2 times, the half-life would be decreased by 2 times. And for the first order reaction, the T half is independent of the concentration. For a zero order reaction, it is directly proportional to the concentration. If time concentration increases, proportionately so many times the T half would be increased. For a third order reaction, you can derive another type of the one. In the third order reaction, we will see this. And from this, since the initial concentration is given, here what are the types of problem that may be asked? Here K2 is a constant, the initial concentration is a variable of T half. Okay. If for this initial concentration, T half is this one, what is the T half when the concentration, initial concentration is changed? That may be asked. It's a direct substitution. Or that can be simplified. This equation can be once again simplified as T half for one concentration is given, T half for another concentration is asked. This is also, there is a general equation. The initial concentration for the second time, initial concentration for the first time, because A is inversely proportional. Here also is n minus 1. Here n is the second order. Therefore, you can put this and you can easily find out what would be the initial concentration A2, what would be the T half, what would be the, and so on. That can be also used for this type of equation. And another thing, what is from this T half of the reaction, and there the amount left, the third equation, amount length after new half-life periods. After new half-life period, that is given by the equation AT. Amount left is equal to initial A naught by 1 plus nu, where nu is the number of half-life periods. And the fourth type of equation we are going to see is the relationship between T 75% and T 50%. You can apply it from the general equation 2 power n minus 1 minus 1. Apply panninga, you will get the relationship between these. Okay, these are the possible formula, and you can apply any one of the formula accordingly. You will get the easier one. Let us start with one thing. I take down this one. What is the relationship between? What is the relationship between T 7 by 8 and T half? T 7 by 8 and T half. What is the relationship between these? That relationship, if this type of problems are asked, the time taken for one is given, the time taken for another fraction is given, you can make use of this equation. You need not go for that one, but if you're going for that one, it's also no harm in it. But it is simple method, and that is a somewhat lengthier one. We will first see, apply this one. K2 into T 7 by 8. Therefore, what is that? This is the 7 by 8 portion is completed. Therefore, what is the remaining portion? 1 by 8 of A naught minus 1 by A naught. It is equal to, if you put this, it is nothing but 8 minus 1 by A naught equal to 7 by A naught. Therefore, K2 into T 7 by 8 is equal to 7 by A naught. Similarly, you can calculate K2 into T half. That is given by, the remaining is 1 by 1 half A naught minus 1 by A naught, or this can be written as 2 A naught, this one, are equal to 1 by A naught. Therefore, now divide this by this, because relationship between this and this is asked. Therefore, in the numerator, keep it in the numerator, keep it in the denominator. You will get K2 T of 7 by 8 by K2 T of half is equal to, for which 7 by A naught, for which divided by 1 by A naught equal to 7. This and this cancel. Therefore, T of 7 by 8 is equal to 7 T half. And if you understand this application, you can calculate what is the relationship between the time taken for this one. What is the relationship between them? You can put any fractional values and apply this equation. You would easily get the formula. Now we are going to make use of this equation. That is in the intermediate, not in fraction, but it is given in percentage. If it is given, how to apply this? If you exercise with this one, you will end up with the same result. However, I have given the simplified one and take down the one. For a second order reaction, 83.33% is completed in 250 minutes. In 250 minutes, time taken for 80% completion. Time taken for 80% completion is option A, 300, B, 200, C, 250, D, 150 minutes. The first answer is a foolish answer, is not? The first answer is a foolish answer. Why? Anybody?
More than 250 minutes will be less.
For 83.33% completion, 250 minutes only. For 80%, certainly it is less than the 250 minutes. Therefore, I'm foolish பண்ணி நம்மளை கொடுத்துருக்காங்க. Then we will apply this formula. How much? 83.33% completion. Here amount completed. Therefore, 83.33 by, what is the time taken? 250 minutes. T1 into, what is this? The amount left free. Here, what is the amount left free? 316.7. எப்படி எடுத்துக்கிட்டீங்க? Given is the x is equal to இவ்வளவு percent. Therefore, A should be 100. Therefore, A minus x is the remaining 16.67. And apply the next for next one. X2 is asked is 80%. Therefore, 80% divided by n r equal to x. அதைத்தான் கண்டுபிடிக்கணுமா? Or T2 into the balance is 20. Yes, this and this, how much times? 5 times. This and this, 50 times. This and this, 4 times. T2 is equal to 50 into 4. It is 200. The option B is the correct option. If you understand this, take down this as a homework. 30% of the reactant is completed in a second order reaction. Second order reaction. In 15 minutes. In 15 minutes. What is the time taken? What is the time taken for 90% completion? For 90% completion. Option A, 45. B, 300. C, 315. D, 600. Okay, do it in your home. And now let us move to the other type of problem with respect to the half-life period. So take down the problem. The half-life of a second order reaction. Half-life of a second order reaction is 2500 seconds. Calculate the half-life of the same reaction. If the initial concentration is increased by 5 times, okay, we have to apply the, what is the initial concentration, what is the T half, what is the final concentration, what is the second type of initial concentration, what would be T half, for which we are giving this equation. T half for the first initial concentration, T half 2 for the second initial concentration. T half of the first initial concentration is 2500 seconds by T half for the second is R is equal to the initial concentration, second concentration is 5 times the first concentration. Power n is 2 minus 1 when this and this cancel. Therefore, T half is equal to 2500 divided by 5 equal to 500. This is the procedure you have to adopt while working this problem in the classwork. In CSIR examination, I have told you T half is proportional to, inversely proportional to the initial concentration. Here the initial concentration is taken as A and its time taken is T half is the 2500 seconds. The initial concentration is increased how many times? 5 times. According to this equation, as the initial concentration increases 5 times, the T half would be decreased, proportionately decreases. So how many times it proportionally decreases? 5 times. Initial concentration time is 2500. 5 times it will be decreased, divided by this one. If you will, the initial concentration is decreased by 1 by 5A. If it is given, if A decreases compared to the first one, automatically T half would be increased. How many times? We will inverse of this 5 times increase. Therefore, 2500 into 5. This is that's like a mental sum you can work out. If you are well acquainted with my discussion, now you will work out, you are going to work out this problem. What is the problem? For a second order reaction, I'm going to 20 seconds. Calculate the time taken for this type of reaction. How to do this one? Just half-life period தான வேண்டியிருக்கு. Rearrange this. How to rearrange this? 8 would be converted into the half-life period. Therefore, it should be converted into the half of the amount. 4. This 4 should be converted into 2 units. If some problem is given, extended to 1 unit, and some may be given into 16 units. What is the total time taken? This is the total time. Therefore, you can't directly convert this. First, convert what is the time taken for this, what is the time taken for this. Sum up, you would get the one. This time taken, if the concentration is 4 units, the T half is 20 seconds. Okay, here for this to this 20 seconds. For this to 6, it's a second order kinetics. Therefore, how many times it is increased? See this, how many times it is increased. 8 to 4 or 4 to 8. The concentration, initial concentration 2 times increase in a second order reaction. In second order, according to the equation, T half would be, as the concentration increases, the T half would be reduced proportionately. Here 2 times increase. Therefore, what is the value T half of this one? Anybody? 10 seconds.
10 seconds.
Okay. Total time taken for this one is how much seconds you want need of it? 30 seconds. Okay. Now you understand this problem. If this is the case, find out what is the time taken for this reaction. What is the time taken for this reaction? Here, for this 4 to 2, 4 initial concentration, 4 is 20 seconds. The initial concentration is 2, the concentration is decreased 2 times. Therefore, decreased 2 times means half-life will be increased 2 times. Therefore, here what is the value? 40. Therefore, what is the total time taken for the completion of this reaction? 61 seconds and so on. This type of problems can be easily mental sum. By mental sum, you can work out it. Okay, now we have given this type of problem that finally we are going to see what are the problems with fast? The amount left or amount consumed. Amount left is we can calculate A naught plus 1 by nu. Nu is the number of half-life period. Okay, take down the simplest one. Half-life of a second order reaction is T1. Calculate the percentage of conversion. Calculate the percentage of conversion. After 2T1, the T of a second order reaction is 2,1. Percentage of conversion after 2T1. Option A, 25%. B, 33.3%. C, 66.7%. D, 75%. What is the correct answer? Here, after 2 half-life period is there. Therefore, what is the value of nu? Nu is equal to 2 half-life period. What is the amount left? Here it is given in fraction or percentage. Percentage is given. If it is percentage is given, the initial concentration A naught is taken to be 100. If fraction is given, the initial concentration is taken to be unit. Therefore, this divided 1 plus 2 equal to divided 33.33 or 33%. Okay. What is this? Be careful. What is AT? The amount left. But problem asked is,
How much is converted?
How much percentage is completed converted. But this is amount left. Therefore, இதை பார்த்த உடனே இதையும் பார்ப்பீங்க, உடனே எதில் போய் டிக் பண்ணிடுவீங்க? 33.3. You are wrong. Here amount converted. எவ்வளவுப்பா? The answer is 66.7%. In this way, you have to work out for this one. Take down the another type of problem. Half-life of a second order reaction is 15 minutes. Compute the time taken for 66.66% completion of the reaction. You can work out this. You can work out this using this equation, and you do the exercise and you find out. It should be very easier. Accordingly, now I'm going to using this AT is equal to A naught by nu plus 1. And what is given? The half-life is 50%. Half-life is 50 minutes. Compute the time taken for 66.6% completion of the reaction. According to this equation, we are need of amount left. At 66.6% is reacted, therefore 3.3 is equal to, percentage is given, therefore A naught is equal to 100 plus 1 by nu. Why I am choosing this? Because the time taken for the half-life period is given. Definitely we can make use of this equation. I thought like this. Therefore 1 plus nu is equal to 100 by 33.3. Therefore 1 plus nu is equal to 3. Nu is equal to 2. how many time would be required? 100 minutes would be required for the 2 news. 1 news equal to 50 minutes. Therefore, 2 news equal to 100 minutes. And you can make use of the same one for the next problem to be exercised in the home. Take down this one. Half-life of the second order reaction is T1. Half-life of the second order reaction is T1. What would be the time taken for 99.9% completion of the reaction? What would be the time taken for 99.9% completion of the reaction? If a percentage is given 99.9, therefore you can make use of this equation. Here, since half-life is given, this equation can also be made use of. Do it into your home and take down the next problem. Half-life for your reaction. Half-life for your reaction. With the initial concentration of the reactant E naught as follows. E naught 10 power minus 2 mole per liter, and the T hat in seconds. When the initial concentration is 5 mole per liter, 240 seconds is the T hat. When it is 4, it is found to be 300. When it is 3, it is 400. The order of the reaction is, you can make use of this equation, n minus 1. Yeah, this one, initial concentration 5 is 240. The T half is 300. And the concentration is 4. Then what is the n? That is the one way you can get the answer. That is the procedure. And for the CSIR examination, just apply your metal sum work, for which we have given the T half is directly proportional to A for zero order reaction. It is proportional to A naught for first order reaction. A naught to A power 0. A power 0 is when that is independent of the initial concentration. For second order reaction, it is as concentration increases, the T half decreases. As concentration decreases, T half increases proportionately. For second order and third order equation, it is the reverse of 1 by 2a square. I have given like this. It is the square in the inversely proportional to the square of the a. And apply this one. Here, the concentration increases or changes, T half changes. Therefore, it is not first order. As concentration decreases, T half increases. But for zero order, it should increase. Therefore, it should be either due to the second order or due to the third order. If it changes with the second order, proportionately increases. Here, as concentration decreases, it is proportionately like 2a square wise, it is increases. First, we will apply for the second order, then we will go for this. How much times it decreases? 1 by 4 times it decreases. How? Initial concentration is 4, next concentration is 4, 5 by 4, 1 by 4. If 1 by 4 times increases, The TF should be 1 by 4 times increases. Therefore, by 4 into the is 240. This and this, it is 60 equal to 300. Yes, it is 300. Therefore, it should be a second order. If it is not like that, this is not obtained, then you can only say it is a third order reaction. And final type of the problem, so far not asked in CSIR examination, but you may think it to be a hardest level, but it is not the hardest level. If you understand the things, it would be also the easiest level. Type of question may be asked in the CSIR examination. The kinetic results of a second order reaction by taking 1 by 80 in the y-axis and the time within bracket t in minutes in the x-axis. The line has x-intercept. Note the point, x-intercept. It is not y-intercept. X-intercept equal to minus 4 minutes. Minus 4 minutes. What is the rate constant of the reaction if the initial concentration A is equal to the initial concentration A is equal to 0.01 molar. 0.01 molar. So how to find out this one? Here graphical representation. So far you have heard about the y-intercept but not the x-intercept. However, it is also possible to work out this one. You should, how to find out this one? I will give you in brief. What is y-intercept? How would you obtain the y-intercept? Now let us assume that K2 or rearrange this so as to plot the amount left, 1 by amount left in the y-axis. To find out the y-intercept, put the x equal to 0 and you will get y is equal to 0. Therefore, y-intercept is nothing but 1 by now. Now, on the other way, is it possible to get the x-intercept? Definitely, by take the y-axis 0, now you would get 0 equal to K2 into T plus 1 by A naught. Now you have to find out this x-axis T. This is x-axis T is equal to 0 now. Therefore, B is equal to minus 1 by K2 into A naught. The x-intercept is nothing but minus 1 by K2 A naught. It is given as minus 4 minutes. Minus 4 is equal to minus 1 by K2 by A naught. And this 4 minus gets cancelled equal to 1 by K2 into A naught is given as 0.01. Therefore, K2 is equal to 1 by 4 into 0.01. Therefore, you have to work out and find out what is the correct answer. In this way, you can easily calculate the K2. If x-intercept is given, so far this type of problem is not asked in the CSIR examination, but it is also possible. Next, we will see the problems in third order reaction, and then we will go for the technology adopted or techniques adopted to follow the first order, various order of the